The importance of test-driven development. Introduction. Software development has become increasingly important in today's age. With businesses relying on technology to carry out their operations, software developers must produce high-quality software that meets the needs of their clients. Test-driven development, TDD, is a development approach that emphasizes writing automated tests before writing code. This approach has become popular in recent years, and for a good reason. TDD has proven to be an efficient and effective way of producing high-quality software that meets user requirements. This video will explore the importance of test-driven development and how it can benefit software development. We will discuss how TDD works, its benefits, and best practices for implementing it in your software development process. What is test-driven development? Test-driven development is an approach to software development that emphasizes writing automated tests before writing code. In this approach, the developer writes a test case before writing any code. The test case specifies what the code should do, and the developer writes code that satisfies the test case. TDD involves a cycle of 3 phases. Red phase. In this phase, the developer writes a test case that fails because there is no code to satisfy it. Green phase. In this phase, the developer writes code that satisfies the test case. REFACTOR phase. In this phase, the developer refactors the code to improve its design, maintainability, and performance while ensuring that all the test cases still pass. The importance of test-driven development. Test-driven development offers several benefits for software development. Here are some of the key advantages of using TDD. 1. Improved quality. Quality is crucial when it comes to software development. TDD helps to improve the quality of the software by ensuring that all code is thoroughly tested before it is released. With TDD, developers write automated tests that check the code's behavior under different conditions, which ensures that the code is reliable and free from defects. 2. Early detection of bugs. TDD allows developers to detect bugs early in the development cycle. By writing tests first, developers can catch and fix errors before they become bigger problems. This approach also helps to identify design flaws, making it easier to fix them before the code is released. 3. Faster development. TDD can also speed up the development process. Since the code is tested continuously, developers can quickly identify and fix errors, which reduces the time spent on debugging. This approach also makes it easier to add new features and modify existing ones without introducing new bugs. 4. Clearer code. TDD encourages developers to write clearer and more concise code. By focusing on writing tests that check the code's behavior, developers can better understand what the code should do. This approach also helps to avoid writing unnecessary code, making the software more maintainable in the long run. 5. Improved collaboration. TDD promotes collaboration between developers and testers. By writing tests first, developers and testers can work together to ensure that the software meets user requirements. This approach also helps to reduce misunderstandings between team members, leading to better communication and more efficient software development. Best practices for implementing test-driven development. While TDD can offer significant benefits for software development, it requires a specific approach to be effective. Here are some best practices for implementing test-driven development in your software development process. 1. Write test cases first. In TDD, test cases should be written before any code. This approach ensures that developers have a clear understanding of what the code should do and what behaviors it should exhibit. Writing tests first also helps to identify edge cases and potential bugs early in the development process. 2. Keep tests simple and isolated. Tests should be simple, focused, and isolated. A test should focus on a single aspect of the code's behavior and should not depend on any other tests. Simple and isolated tests make it easier to identify the source of errors and help to ensure that the code is reliable and free from defects. 3. Refactor regularly. Refactoring is an essential part of the TDD process. After passing a test, the developer should refactor the code to improve its design, maintainability, and performance. Refactoring should be done regularly to ensure that the code remains efficient and maintainable. 4. Use continuous integration. Continuous integration (CI) is an automated process that builds, tests, and deploys code changes. CI can help to ensure that code changes are tested thoroughly and that any issues are identified and fixed quickly. CI also helps to ensure that the code is always deployable, making it easier to release software updates. 5. Emphasize collaboration. Collaboration between developers, testers, and other stakeholders is essential for successful TDD implementation. Developers should work closely with testers to ensure that the software meets user requirements and is thoroughly tested. Collaboration can also help to identify design flaws and potential issues early in the development process. Conclusion: test-driven development is a development approach that emphasizes writing automated tests before writing code. TDD offers several benefits for software development, including improved quality, early detection of bugs, faster development, clearer code, and improved collaboration. To implement TDD effectively, developers should follow best practices such as writing test cases first, keeping tests simple and isolated, refactoring regularly, using continuous integration, and emphasizing collaboration. By adopting TDD, developers can produce high-quality software that meets user requirements and is reliable and free from defects.